Hello viewers, my name is Damilare. In this lesson, we're looking at the topic oxides of carbon. Oxides of carbon. What are oxides of carbon? These are compounds formed when carbon is heated in oxygen or air. That means if I say air, I'm still talking about oxygen to form carbon monoxide, that's CO. That is, if the oxygen is not enough, it will form carbon monoxide, just like smoke. When you are burning firewood and there's not enough air, you'll be seeing smoke, that's carbon monoxide. Or it should form carbon dioxide, that's when there's a complete combustion. That's why we said it depends on oxygen availability. So let's look at carbon dioxide as a case study. The person that observed this gas was Van Helmont. You can remember using controversial, the con, that's CO, the true, that's 2, va, that's van, share, that's H in Helmont. It is a naturally occurring inorganic compound. Inorganic in what terms? That means it is from a mineral resource. It is from air. So we call it inorganic compounds of carbon, and the atmosphere contains just 0.03% of this carbon dioxide because of the danger that is in it. It doesn't support combustion. That means anywhere fire is burning, it will rather extinguish it, and that's why we use it as a fire extinguisher. But it is important to green plants, that's during photosynthesis. Now we'll be looking at how do we prepare carbon dioxide. So to prepare carbon dioxide, just use these mnemonics that I have here. That's AT, H-A-T, AT. Then F-R-O-M, from. Then C-O-N-G-O, Congo, AT, from Congo. Maybe someone is wearing a hat and that person is from Congo. Letter H simply means heating. It means if I want to prepare carbon dioxide, I can heat a metallic trioxocarbonate 4, except the one I call bank. The bar is the barium carbonate. So heating that one will not work. The same thing, end of sodium. Heating sodium carbonate will not work. Then K, potassium carbonate. Heating it will not work. But heating any other carbonate, it will produce carbon dioxide. For example, CaCO3, calcium carbonate. If you heat it, it will give you CaO and it will give us CO2. So, but for all these ones you see like sodium carbonate, if you heat it, it cannot give us CO2 and MaO. So because it will, it is not always being affected by heat. Now, another way of preparing carbon dioxide after letter H of the mnemonics, AT from Congo. After H is AT. A and T. A means acid, T means trioxocarbonate. It means if I mix acid with a trioxocarbonate 4, I should be expecting carbon dioxide and water. But the acid I will use, take note that H2SO4 is not the best, because if you use H2SO4, for example, with calcium carbonate, so the calcium of the calcium carbonate joining with SO4 may still coat with the limestone of the calcium carbonate. Remember that it was calcium carbonate and H2SO4. So the calcium sulfate may still coat with the marble chips, So and then it will prevent further reaction. So and that's why it is not the best. Now another thing we have is letter F. So what is letter F? That's fermentation. It means if I want to prepare carbon dioxide, I can do fermentation. So what is fermentation? That's, for example, when you have all these sugary substance, like maybe even your garri, when you soak it in water, it can ferment when you leave it for a long period of time. So we call it alcoholic fermentation of glucose. So let's take glucose, for example, C6H12O6. So the fermentation, we are not adding anything, no oxygen, so we just leave it so it can decompose or it can break into ethanol. That means ethanol will be formed. 2 moles out of the 6 carbon, there will be 2 of this ethanol, and there will also be 2 of carbon dioxide. So it means we have been able to prepare carbon dioxide from fermentation. Then another one is ROM. So what is the ROM? I say add from. The ROM means reduction of metallic oxides. Reduction of metallic oxides. So how can we reduce a metallic oxide? Just like iron 2 oxide. So this iron 2 oxide, just add carbon with it. The carbon will take the oxygen and iron will be produced. That's reduction of iron 2 oxide. So I can use carbon to reduce iron 2 oxide. So that carbon will now become what? Carbon dioxide. The same way, we can also use carbon monoxide, that's CO. When it joins with the iron 2 oxide, it will pick the oxygen and also form carbon dioxide. So that's out from remaining Congo. The Congo is CRO. The C, combustion. Combustion. So what is combustion? It means complete combustion of hydrocarbons. Complete combustion of hydrocarbons. That means that combustion means you should add oxygen. So that's why I put CO, C combustion, O oxygen. Add oxygen to hydrocarbon. Example of hydrocarbon is methane, CH4. If I add CH4 plus oxygen, I'll get CO2 and I'll get H2O. So meaning I've produced carbon dioxide. So these are the ways of preparing carbon dioxide. Now, what are now the physical properties of carbon dioxide? You can say sail to Scotland. Sail, just like using ship to sail to Scotland. What is S and what is L? The S is slightly soluble. It means carbon dioxide is slightly soluble in water. Then the L is litmus paper. It means, remember that carbon dioxide is acidic in nature. So meaning that when you put moist blue litmus paper in that carbon dioxide, it will make it become red. Then that's for sail. Scotland, another letter S, that's solidification, meaning that your carbon dioxide can become solidified. So remember, it's a gas, it can be solidified when the temperature is minus 78 degrees centigrade, it becomes solidified. Then the next letter C from Scotland, the C, the O, the T, that's colorless, odorless, and tasteless. It means CO2 gas is colorless, is odorless, and is a tasteless gas. Then the next letter L. So as we have mentioned L earlier about litmus paper, but the other L we use here now is liquefied. The same CO2 gas that we said can be solidified can also still be liquefied. So that's uncool. If you cool it, it readily liquefies. Then the last letter D, it is denser than air. It is denser than air, like heavier, so than air. Now let's move to chemical properties of carbon dioxide. When we say chemical properties, that means when we add carbon dioxide with another chemical element, what are we expecting? The first thing, you can use ambassador coming. Ambassador, that means an ambassador is coming. So this AMB, then R is representing ambassador. Then this coming is like this. So what is the letter A? That's acid, meaning that a carbon dioxide, remember the chemical properties, it can form carbonic acid. That's H2CO3. How will it form this H2CO3? When that carbon dioxide, when you add it with water, it will give you carbonic acid. So that's the chemical properties. After A, which is acid, we also have M. But this M, we relate it with G. We also relate it with CO. So it means magnesium. The M is representing, M and G is magnesium, meaning that carbon dioxide, when magnesium is burning, so as it's burning, you should know that carbon dioxide will not does not burn, but a burning magnesium will continue burning even it enters inside the carbon dioxide. You know, normally any carbon dioxide will extinguish what is burning, but carbon dioxide doesn't have the power to extinguish a burning magnesium. So carbon dioxide doesn't have the power to extinguish a burning magnesium, and that's why it will still keep burning. The magnesium will still keep burning even in the presence of carbon dioxide. That's another chemical properties, and that's how you can see Mg here that is burning already. If it joins with CO2, then it will still continue such that it will even take oxygen from carbon dioxide and form MgO, while carbon will be left. That means the black product. So it means the burning still continues even in magnesium. So we have seen the A, the M coming with CO, then remaining the B and the R. So another chemical properties is B. B represents base, but the base here is soluble base, which we call alkali, meaning that carbon dioxide can form triazocarbonate 4. Carbon dioxide can form triazocarbonate 4 with alkali. That means this is our carbon dioxide. If I join alkali like sodium hydroxide, so it will form the triazocarbonate, that's sodium carbonate, and then water. So that's another chemical properties. And this sodium carbonate, if we keep adding that carbon dioxide, that sodium carbonate will now become the one that will have hydrogen in it. That means sodium hydrogen carbonate, or you say sodium bicarbonate. So just like the way we do in lime water, when we take lime water with carbon dioxide. So that's exactly what will happen here. Then that's for letter B. Then the last letter is R, from ambassador, coming. So R is reduction. It means reduction of what? Carbon dioxide to carbon monoxide. It means carbon dioxide has the ability to reduce to carbon monoxide. That's when that carbon dioxide reacts with carbon, it will be reduced to carbon monoxide. So the next thing we'll be looking at is tests. How do we test for carbon dioxide? How will I know that this thing is carbon dioxide? To do the test, take lime water, that's calcium hydroxide. Once you take lime water, add it to that carbon dioxide. So what will it give you? It will give us limestone, and then it will give us water. So that limestone is, they call it milky color, to give you a milky form. But if you keep adding more of that carbon dioxide, the calcium carbonate will now become calcium hydrogen carbonate. So of which, if you now heat it, if you heat this calcium hydrogen carbonate, then you have a clear compound again, clear calcium carbonate. So that's how to test for carbon dioxide. Now, uses. What is the uses, or what are the uses of carbon dioxide? Just use FRSC, that like Federal Road Safety Corps. They have a plan, FRSC plan. The F means fire extinguisher. We can use carbon dioxide to extinguish fire. So because it's a heavy gas, it will extinguish that fire. Then the next letter is R. That's refreshing. It means carbon dioxide has a refreshing properties. That's why it is used in Coca-Cola. So because of the special or pleasant taste. So that's refreshing. The letter S, that's survey process. Carbon dioxide can be used for survey process. That's preparation of sodium carbonate. So when it joins with sodium hydroxide. Then apart from sodium carbonate, it can also be used to produce sodium bicarbonate. So that's NaHCO3. That's for letter S now. Then letter C, cooling agents. That's a refrigerator, as a refrigerant. So it will solidify. So meaning that carbon dioxide can be used as a cooling agent. Then the next letter is P. So the letter P means photosynthesis. Carbon dioxide can be used for photosynthesis because that's what plants absorb. Then letter L is leavening agents. Can be used as a leavening agent. That's in baking bread. To bake bread, it will be used as a leavening agent. That means to make it swell. Then the next letter is N. So N means nuclear reactor. In nuclear reactor, that's your machine. So it can be used as a coolant to cool, because that nuclear reactor has a great energy, so it can be used to cool it. So that's the end of carbon dioxide as one of the oxides of carbon. What of the second oxides of carbon, which is carbon monoxide? First thing about this is that it's a poisonous gas, and it is colorless. It doesn't have color, and just 0.5% of this carbon monoxide is very dangerous in air. It can cause death if it is in air, but 0.1% alone in human body is also dangerous. Now, how do we prepare this carbon monoxide? So you can just say, I see dark red, I see dark red, or I see dark lights. So anyone you call it. So the letter I represents I, then C, letter C is represents C, I see. Then though dark is D-A-R-K, but you can use D-A-L-K. So if you use R, that's dark, L, maybe dark light or dark lemon. So I see dark red. The letter I in preparing carbon monoxide is incomplete combustion. That means incomplete combustion of a compound. When you take a compound like an hydrocarbon of CH18, so if you add oxygen and you don't allow the oxygen to burn completely, it will give you carbon monoxide and water. That's I for incomplete combustion of a compound, IC. Then the next letter is letter D. I call it dehydration of alkanoic acid. And that's why I said dark. Al that is there is for alkanoic, dark. So that means dehydration of alkanoic acid by what? H2SO4. It means if I take alkanoic acid like methanoic, you know methanoic acid is HCOOH. So this metanoic acid, once I bring conc H2SO4, it will drain out water H2O and it will remain CO. So I've prepared CO using what? Conc H2SO4 to dehydrate alkanoic acid. Another alkanoic acid is ethane 1,2-dioic acid, dioic. So when I also use that same conc H2SO4, it will remove H2O, that's minus H2O. The CO that will remain will now be double, or when you remove H2O, it will now remain CO and CO2. So meaning I've produced carbon monoxide. Now another thing is reduction. Remember I said I see dark red. The red now is reduction. So I can prepare carbon monoxide by what? Reducing carbon dioxide. So if I have carbon dioxide, I can reduce it by using carbon. So when I add carbon to carbon dioxide, I will get the carbon monoxide, 2 moles of CO. Now, physical properties of carbon monoxide. That means physically, how will I identify CO? Just use colons, just like Corinthians in the Bible, colons. The C and the O represent it is colorless, it is odorless. But the L that is here is lighter. That means it's not dense. Remember, CO2 is dense, but you can say from CO2, no 2 extra to make it denser than air. But this one is just CO, so it's not dense, it's just lighter than air. Then letter I that is there is insoluble. This one is not soluble in water, unlike CO2 that is slightly soluble in water. CO2 is heavy, so it can easily go down into the water, but CO, it will just be floating, so it means insoluble in water. So but it can dissolve in ammoniacal copper 2 chloride. CO, it can dissolve in ammoniacal copper 2 chloride. I can say just like calculator, calculator, so cocoa. So now from there we can move to the next letter N and T. That means it is N is neutral. It is neutral to litmus paper. That means it is not like CO2 that we say is acidic. This one is neutral. Co is neutral. Then the letter T is now tasteless. It doesn't have any special taste. Now we move to chemical properties of CO. So that means what are the chemicals we have to CO and what are the things it will give us from CHO, just like choir. Just the letter I will be missing. So what is letter C? Combination reaction. It means carbon monoxide can be combined with oxygen to form carbon dioxide. That's combination. Then letter H, hemoglobin. Carbon monoxide, it can act as a poisonous gas that can form carboxyhemoglobin. When carbon monoxide joins with hemoglobin, which is in the blood, it will form carboxyhemoglobin in the red blood, and it will be affecting distribution of oxygen. So that is the letter H, that's hemoglobin. Then letter O. So we have joined the O. Okay, so we have seen letter C, combination, H, hemoglobin, the O, oxygen. So it means the oxygen was what we said earlier, that combined with oxygen. The letter R is now reducing agent, meaning that chemical properties, carbon monoxide can act as a reducing agent. It can reduce lead 2 oxide to ordinary lead. That means taking O from lead 2 oxide, so it will now form carbon dioxide. Now the next thing, how do we test for carbon monoxide? How do we test for carbon monoxide? Now the first thing is burning it. Increase the air in carbon monoxide so that it will now form carbon 4 oxide and the color will become blue. So you see a blue flame. When we burn carbon monoxide in enough air, it will form blue flame of carbon dioxide. And then the same test we did for carbon dioxide can now be continued. That's turning lime water milky. Then so it can be used for coal gas, carbon monoxide, just like we talked about popcorn producer gas from carbon monoxide and nitrogen. Then water gas from WHO, so that's hydrogen and then oxygen. So meaning that we can use it to form coal gas and gaseous fuel. And it can be used as a reducing agent. That means it will trap oxygen from another compound in metal extraction, like iron 2 oxide can pick oxygen from it. It can be used as a constituent of gases, constituent of gas fuel, like constituent of producer gas. So producer gas and water. So and it can be used to produce methanol, that's CH3 OH. So that's what I have for you today from the topic oxides of carbon. Thanks for listening.